come back from lunch. I'm happy now to introduce Richard Hartmann from Grafana Labs, giving us some insights on observability.
Hello, everyone. Hopefully some of you are awake after all the food, but I'm going to try to make it interesting enough for you to stay awake. So super quick of who I am, because most of you probably don't know me here. I work at Grafana. I'm a Prometheus team member. I'm also part of OpenTelemetry. I've had various hats at CNCF, sitting on the Governing Board, Technical Oversight Committee, chair of the Technical Advisory Group, also CFP handling for KubeCon a few times, because I see all the t-shirts. Also specifics to Siemens. Most of my life I have been doing industrial stuff and large stuff, which is kind of a dear place in my heart, even though I do software now. So if any of you have a medium voltage factory or something where you can show super cool stuff and need an internal talk, maybe we can trade. Also for the people in here, Modbus exporter and SNMP exporter exists, so all your industrial stuff you can just shove directly into cloud native things if you didn't know this yet. So I only have 2 slides which even show a little bit of visualization, the rest is going to be different stuff. One of the problems we have today is, can you hear me? Because I have okay, good. One of the problems we have today is you often have different systems for different parts of your stack. This can mean something is good when it goes up here and when it goes to the right over there, or it may be orange here, it might be red in the other thing. It might have a different name, it might need a different click path. You lose a lot of momentum, of mental energy when you need to switch between a lot of different systems instead of having a holistic design which is underlying everything. The problem is this slows you down, and this takes up a lot of mental energy. And by extension, it makes it harder to understand what is actually happening. And if it's harder for you to understand your systems, again, by extension, it is also harder for you to pour your human understanding into machine code or into runbooks or into whatever. It slows everything down. So let's rethink a lot of this, and let's really get back to the basic of what observability actually is. This is about how humanity deals with data. And the thing about how humanity deals with data is we always went through the same optimization chain again and again and again and again, ever since we have had written records. There's one thing, this is Janitza, not Siemens, I'm sorry, but the thing which you see here is A, graphs, and B, events, logs, call them whatever you like, doesn't matter the name. The point here is this. The end state of any optimized system is numbers first for most everything, and only where it is really important, because you have Netzwischer in German on your medium voltage, or if you have a microburst on your network or something where you really need to go into the details of a fault or something, there you have logs. Also due diligence, security, things like this. So let's go through a few examples. This is the Stahlschlüssel. For those who speak German, it's obvious what it is. It is a book where... No? Okay. Schlüsselt den Stahl auf. Anyway. So this book has been in publication in the first version since the late 1800s, early 1900s. And literally every single type of steel which is being produced at commercial volume on Earth is in this book. All the physical properties, all the tests which they ran, all the different properties, what is the components, how do you need to heat it, to heat treat this, everything is in this book. All of what we have is reduced into numbers. This is a log book, the classic example for logs, where they threw the log overboard, they counted the knots, from this they could deduce the speed, from this they could deduce where they are on the high seas, and if you don't know where you are on the high seas, you starve. It's very easy. So this book was sacrosanct from the perspective of everyone on that ship, because literally their life depended on it. Over time, they started putting on more and more information which was externally relevant about the ship, who got paid, what cargo did they take on, all of those things. This is the oldest letter which we as humans know of, like the oldest letter we have. It's 3,500 years old, roughly. It's a complaint letter about a wrong delivery of copper and the buyer is still making provisional payment, but he's complaining A, about the grade of copper, and B, about how the seller was rude to the servant of the buyer. And this is the oldest writing we have, roughly 5,000 years old. This most likely tabulates who owned what slaves at what point in time. The point here is this optimization chain of how humans have dealt with data has always been the same. Something is worth doing, something is worthwhile. So you write down the complete story. This and that king had this many cows at this and this state, and the weather was fine, and we had this food, and we sing and dance and whatever. As you keep doing this more, as this keeps being worthwhile, it starts to become too expensive. So people have started extracting logs, key events about or from the whole story. As you keep doing this more, as this keeps being worthwhile, again, there comes a point when this becomes too expensive. And then every single time, over the thousands of years where we have had written records, humans have always done the same thing. They have put stuff into numbers. Numbers are great. You can store them really efficiently and effectively. You can do math on them. You can do large-scale statistical analysis on them. You can also call it big data, machine learning, AI if you want to. You can do a lot of stuff really cheaply at scale with information once it is in numbers. Again, if you have due diligence requirements, also use logs. But like you see this in every single industry, in any single established industry. You consume power at home, you get a bill from the power company. They tell you a number, that's your consumption. They tell you another number, that's the price per unit. They tell you yet another number, that's the price you have to pay. And they tell you a number where you have to wire all the money. It's all numbers. By extension, my argument here is that IT as a field is not super far in the mature stage yet. Of course, most areas of IT are still logs first. There's two notable exemptions. A, internet service providers or generally large-scale networks. Those are already numbers first for the simple reason that the internet is kind of the biggest information thing we have. They basically hit this 20, 30 years before the second thing, which is numbers first, and that's cloud native. All the cloud providers internally run purely on numbers first. Speaking as a Prometheus maintainer myself, there is a reason why you will find pretty much no one who is using Kubernetes successfully and not using some flavor of Prometheus, at least if they're not using Prometheus proper. This even goes back to Google when they designed Borg and Borgmon, which were tightly coupled, same as Kubernetes and Prometheus, which are now the open source reimplementations of those two tools. Point here is this optimization chain was always the same. So let's look at a few buzzwords and dispel the myths. So observability is kind of a buzzword. As per usual, when something is a buzzword, there is a kernel of truth, but people just keep using the new name for the old stuff, and they charge more or they get their promotion or whatever, and they change nothing about their behavior. Kind of common knowledge, kind of a trope by now. There is some kernel of truth to this observability degradation, where who here knows what cargo culting is? Okay, so cargo culting is a term from the Second World War. Their Pacific Islanders observed weird people coming, and they cleared the forest, and they built little fires or big fires, and they did their marches and everything. And all of a sudden, the gods started sending gifts from heaven, as in planes and ships brought cargo for the war effort. These Pacific Islanders, to this day, have proto-religions which are based on basically doing marches, building light towers and everything. They observed behavior, they observed success, and the desire to replicate the success was so strong that they just made everything up in between as best as they could. And again, even though today they know how this worked and what happened, they still have proto-religions which still have those traditions, as you might call them, because it is so deeply ingrained in humans that when we see success, we want to replicate the success. That's probably true for a lot of people who hear about all the great things you can do with Kubernetes, and then you sit before this wall of what's even happening. Like, there is there is something in between. And part of this is you need to be able to understand the systems. There are more functional and negative definitions of observability, like if you cannot ask me questions on the fly, it's not observability, or if you can only determine that something is broken and not why something is broken, is not observability. But those are, again, functional and negative tests, not positive and scientific tests. Also, as a side note, I've seen observability start to be numbered. 4.0 is the highest I've seen up to now, so why don't they just go up to 11 and we're done? Because everything goes up to 11. But point is, this stuff has been around, like the fundamentals have been around for thousands of years. There is no need to version it, it's just a need to do it proper. And if someone versions it, they're trying to sell you something. So what is the scientific definition of observability? Initially, it goes back to Carl Friedrich Gauss in the 19th century. Observations are approximations of the truth, and you have to take a little bit more measurements that you absolutely must to come to a reliable observation about whatever it is you're trying to observe. And then from control theory, when basically industrial systems became too large for this one person to know everything, and they had to pour a lot of money and energy into researching how you could control more complex systems, Rudolf Emil Karman defined that observability is a measure to which extent you can determine the internal state of a system just by looking at the outputs. And that is all you need to know about observability to be able to reason about the problem space, disregarding all the buzzwords, all the sales pitches, all the numbering, all the negative and functional definitions. This is the only definition which actually matters. Of course, it tells you clearly that what observability is at the core is you need to be able to emit enough information about your system to be able to deduce the internal state. In things like initially I need more data, and as things become more advanced and more stable, I can get away with less data, and I don't need to pay as much for the data. I can put the more complex full story and key events into numbers. All of this flows from this initial definition, that you need enough observations, enough data to be able to deduce the internal state of whatever system it is you're running or maintaining or someone else is maintaining. Let's tick a few other boxes of buzzwords and of stuff which is often mentioned in the space. Complexity. I personally like to discern between two different types of complexity, fake complexity and real system inherent complexity. Fake complexity, just optimize it away, please. It's useless. Just as far as you can, get rid of it. Real system inherent complexity you cannot get away from. You can move it, but you cannot optimize it away, because this is part of what makes your business. If you are a bank and you store how much money someone has, you cannot get rid of the complexity of storing that data. It needs to live somewhere. You can and arguably should compartmentalize it so it's easier to handle and easier to move and easier to reason about. And you should distill it meaningfully, again, coming to observability. But again, it cannot be reduced. Also important for anyone who is working in a regulated industry, something like regulations or compliance or something might appear as fake complexity, but in your field, it is absolutely 100% real. So this is something you cannot optimize away. Because I've seen people trying to optimize this away. Please don't. You get into trouble. So what is a service? A service is a compartmentalized unit of complexity. Has different owners and teams. I personally like to say contracts, not APIs, because contract is something I sit down, I negotiate, I write it down. Everyone agrees to the written. I can't just say, oh yeah, whatever, and I can't just change it, because if I change a contract, I need to actually sit down with whoever my contract partners are and actually make a change to the contracts. So contracts has a lot stronger connotation than just API. Layers is another term for this whole concept or problem space, where anyone who's familiar with networking, you know that you have the physical layer, then you have the MAC layer, you have the local layer, you have the routing layer, you have the UDP, TCP, blah, blah, blah. And all of those layers do not care what the one above or below does. At the time when TCP IP was initially specified, no one knew that we would have wireless. But it doesn't matter, it just works. And there's obviously tons and tons and tons of interfaces in your life. Even if you cook your lunch, every single time you don't grow every last cucumber yourself. So your life is riddled with interfaces and with complexity. Part of the cloud native stuff is cloud native. Yes, you can horizontally scale, blah, 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 blah. It's cheaper and easier than vertical scaling. And all of this is true. It's kind of boring. The point about cloud native, to me, is it allows different people, different teams to talk to each other less. Because I have my contracts, I have my APIs, I have my clear definitions, I can test against them. So as long as the other people keep doing and keep providing the services at the level where I need them to be provided at and which we agreed upon, I don't need to talk to them about what is happening, because I can just rely on it. And if it doesn't, I have a clear interface of where I can go in. But also, like this benefit of A, horizontal scalability, and B, having harder API contracts and less requirement to talk to each other and synchronize in live meetings and such. I have to pay for this sometime. And the way I pay for this is we as an industry, we within CNCF, deliberately broke up old compartments of complexity into smaller, more nimble parts of complexity. Previously, you had your mainframe, you had your Unix system, you had this one monolith, and you knew how the RPCs were wired internally. But you basically have top or whatever, and you see what is happening, and this is your interface to the bucket of complexity. But now you don't have one monolith, you have 100 microservices. And all the internal wiring and everything is deliberately exposed, because that makes it easier for people to move more quickly, to scale it more easily, and again, talk to each other less. So all of this previously hidden and well-contained complexity is all of a sudden deliberately exposed to you, to your peers, to everyone. And this is what makes part of cloud native so hard, and what makes part of Kubernetes so hard, and to basically make it impossible to understand without proper tooling. And B also is why all the last generation tooling is having so much issues with trying to scale to cloud native scalability, because they were built with a fundamentally different world in mind. This was the time of monoliths on mainframes, big Unix irons, and all of those things, not of small, nimble, horizontally scalable microservices, hundreds and thousands of tens of thousands of them. Something on SRE? Who knows what SRE is? Maybe. Let's agree on another one as well. We have two now. So mine would be site reliability engineering, which is how Google calls basically keeping stuff running. And it's something which has seeped into all of cloud native. Again, a little bit of a buzzword problem of people just calling the old stuff by the new name and demanding a raise. SRE is at the very core about error budgets. Now, if I take a random company and I have an engineer, that engineer gets promoted and retained and gets their raise based on features which they ship as fast as possible. Now I have a team lead. That team lead is paid and retained and promoted and compensated and gets a raise for a happy team. Now I have a product owner. That product owner wants the roadmap to be shipped. Now I have someone in research and they want to A/B test that whole system to really get at what is in there. So everyone has different incentives and everyone keeps fighting each other. Of course, the company they work at has literally set them, am I still audible? Of course, this is, okay. Has set them up to fight against each other by giving all of them different priorities and no way to reconcile those other than a lot of meetings or escalations. From the beginning, Google had a different mode of operation, and that is error budgets. Error budgets are how good is the service from the perspective of the user. Maybe customer, maybe internal customer, paying, non-paying, doesn't matter. The users which consume the service. Now, if my developers write really, really brittle code and it breaks all the time, and the operational people need to fix it all the time and need maintenance windows and everything, because the code is so brittle, at some point they are not allowed to ship new features anymore, because everyone needs to keep fixing the stuff. If I'm barely scraping by and the stuff is just stable enough that my developers can ship the features quickly enough, The research people are really unhappy because they cannot do any A/B testing because they would need to be a little bit less reliable from the perspective of the end user to do their A/B testing. By giving everyone the budget of how well do users think the service is working, everyone is suddenly working with the same underlying numbers. If they negotiate between a big initiative and just keeping the lights on, all of a sudden they use the same numbers, the same language, and the same budget. And if they hit the budget limit for this quarter, no one is shipping any new features anymore. No one is doing any A/B testing anymore. They just keep this thing running. So all of a sudden I align all of the incentives across the people. That at the core, to me, is SRE. There's SLI, SLO, SLA. Very simple. SLI is service level indicator, what I measure. Service level objective is what I need to hit internally. And service level agreement is where if I break it, I actually have to pay money back or whatever. There is another term, KPIs, key performance indicators, and that's literally the same as those three, just all three mixed into one, which is why I prefer those three. Of course, it makes it clearer about which aspect of this I'm talking about. But now you can go back to your manager's manager and be like, hey, these are the KPIs, and we call them SLI, SLO, SLA. So next time you see the SLO dashboard, it is part of the KPIs. And all of a sudden also you start speaking the same language. Because what all of this does is if you start having the same underlying basis of data and the same nomenclature and everything, if you use the same tools across the org, and I mean tool sprawl is a little bit of a problem here, as just having a few conversations earlier, everyone has a shared incentive to invest into the same platform, into the same tooling. You have this really awesome database expert, and they go in and they optimize this one database, this one dashboard. Everyone benefits. You regularly have discussions between management and engineering. Okay, now it's called the SLI or the SLO/KPI dashboard, and they start using the same language. This can really, in particular in large companies, unblock a lot of things where people would want to work together, but it is made unnecessarily hard because the tooling is just not in place. And the biggest perk of when you go down this path and when you decide to go down this path, who here knows this thing? You go into a meeting, you have, let's say, 8 people, and you start the meeting by discussing which of the 7 sets of numbers are least wrong. Because everyone brought different numbers. Everyone has a different view of the world. If you use the same dashboards, the same reports, the same alerts, the same underlying data, you have a similar worldview. Your perception of reality matches the perception of reality of the other people. Without going too far, we can also see in democracy what happens when that shared worldview breaks down. But on the positive side, by building a shared understanding of reality, everyone agrees on the fundamentals. You don't have to fight about, no, this number is wrong or something. Maybe you need to improve it. Okay, then we improve it. Maybe we need to break out this one thing into this other team's numbers or whatever, then we do this. But other than optimizing and improving the underlying data, the validity of the data is not put in question by everyone all of the time anymore. And you don't have this one group which is kind of not really working and they kind of want to escape responsibility, so they kind of do this fear, uncertainty, doubt about the number of the other team every single time. No, it's all the same numbers. This is one of the most overlooked but most foundational, transformative dynamics you can have, in particular in a large company. One final word on the fundamentals on alerting. If you sell shoes and you have 10 databases and 9 of the servers are literally on fire, like as in flames coming out of the server, and your customers can still buy shoes, they do not care about your databases being on fire. The only thing which matters from this perspective is, are the users, are the consumers happy? Can they consume the services at the level they expect to? Everything else doesn't matter. So by extension, the only thing which you should be calling someone for, which you should be waking someone up at 3 a.m. in the morning, is something which is imminently, as in soon, or currently customer/user impacting. Everything else raise a ticket, fix it during business hours. And if something becomes enough of a problem, from we can do this during business hours to we need to wake someone up, then wake someone up, whatever. But the vast majority of those would-be alerts can just wait until the next Monday during business hours, and someone can fix it in peace and quiet and not have to explain their family why they can't join this one super important thing, or why they didn't get any sleep and can't go play with the kids or whatever. It's super important, and it makes people happier. It makes yourselves happier if you're an IC, and if you're a manager, it makes your teams happier. And happy people are productive people. So let's speed run through a few technologies. Prometheus, who here knows what Prometheus is? Okay, so I'm going to be real quick. Maybe a tenth don't know. It's basically the open source copy of Google's Borgmon. Borg and Borgmon is what allowed Google to grow as much in the late 90s. Borg is now Kubernetes. Borgmon is now Prometheus. Details not quite the same, but whatever, speed run. It's a time series database, as in it stores numbers which change over time. Lo and behold, that's precisely what I said initially, like numbers are the most optimized form of data. There should actually be tens of thousands of instrumentations and exporters. There's literally tens of thousands of interfaces which people have already built for data to be put into Prometheus format, because Prometheus is so ubiquitous. Anything in CNCF land is Prometheus metrics. If it's numbers, it's Prometheus. OpenTelemetry metrics is also compatible with Prometheus, but like the actual generators are all Prometheus client libraries. Kubernetes, all of those. Time series are just numbers which change over time. So I write down the temperature in this room every 5 minutes, and I write this down. I plot this on graphing paper. That's a graph. That's a time series. Very easy. I can merge individual events, like I count how many waters have been given out at the counter, how many coffees. That's a counter. I count how many people are in this room. That's a gauge. It goes up and down. There's others, like, doesn't matter. Yeah, it's a cloud native default. You will not find anyone who's successfully using Kubernetes without a flavor of Prometheus. And even if they are or pretend to be, the way which Kubernetes emits data about itself is literally the Prometheus exposition format, or OpenMetrics these days. It is highly dynamic. Instead of having a hierarchical data set where you have your region and you have your customer and you have your deployment and your version, and then your boss comes and tells you, okay, I need everything by customer. And they're like, oh. So you write a for loop and you descend all those different branches. You have a huge array of all the data. You write another for loop, go through the array, and then I tell you, great, now I need this by deployment. And you're like, oh. You have labels attached to your data, and this is flat. So you can build an n-dimensional matrix with those labels, and you can slice and dice your data as you need it. Sounds hard, is simple. There's one single language to interface with all of the data within Prometheus. It doesn't matter if you export, if you alert, if you build a dashboard, if you do whatever. It's really easy to read and to emit this data. This is how it can look. I know people who just print F from their C and dump it in a text file, put this on an Apache, and that's how they do their instrumentation. It just works, has worked for 10 years. And this is the labels which you can see. So you can just write whatever. PromQL is a functional language for vector math. The most important part is the vector math. Any large-scale data analysis, be it weather predictions, be it all the AI/ML. The reason why NVIDIA gets so much money these days is because they have processors which can do vector math instead of imperative math like Intel CPUs or generally CPUs. And this is basically a really easy way to write a query, and it does not matter if I have 0, 1, or 10 million results. I write this query once. I don't have to descend any trees, write any for loops, anything. I write this once, I'm done. Yeah, you have advanced mechanisms. You have those slides anyway, so you can just look through them after. Any current hardware, you can do 1 million samples per second, no problem. Any modern server you can do in the order of 100 million active time series, as in data which has been received within the last 2 hours. For more, you need horizontal scalability alternatives to Prometheus. Like Mimir. Mimir is a Prometheus compatible project based on Prometheus code by Grafana Labs. It's horizontal scalable. It also supports Datadog and Graphite and a few other things, but at the core it is Prometheus, also obviously OpenTelemetry. Mimir is for metrics, for those who know what LGTM, that's the M in LGTM. This scales to more than 8 billion active series. We have not had a single customer or user, open source or commercial, doesn't matter, who has run into technical problems scaling Mimir. They all ran into commercial problems. Of course, their manager's manager at some point is like, why are we paying so much? Can you optimize this? But like, it scales beyond what any large customer or user has ever needed. It's even faster than Prometheus. And yeah, OpenTelemetry, Datadog, Graphite, Influx, you can just send the data in, and also you can use those in the commercial version, those query languages, to get stuff out. Numbers from Grafana, those are already a little bit old, we are better now. But basically, it's 1 billion active series. We had 1,500 machines, 7,000 CPU cores, 30 terabytes of RAM. Again, this is why we hit financial limits, not technical limits. Loki for logs. It follows the same label-based system as you just saw with Prometheus. It also, yeah, but it is for logs. So you can store basically everything. It doesn't have to be text. It's blobs on the technical level. I know someone who stores images for his self-driving car project in there. It works. I don't know if I would build my own self-driving car, but it works. At least the Loki part. It also is horizontally scalable. Scales beyond what people need, basically. We also have Bloom filters these days, which are, like, one of the things about Loki is we deliberately do not full text index, because full text index is, except for security due diligence, always too expensive, and we have the numbers to back this up. But sometimes you need to do full text search, and Bloom filters are basically a happy path in between just label indexing and full text. If you want more on this, just catch me later. Looks very similar. You just have a timestamp. Of course, logs are events, so they are tied to a specific time, and that specific event is tied to a specific time. Whereas again, counters are aggregated forms of events, so they don't have a specific per sample timestamp anymore. And the rest looks basically the same. Some numbers, again, internal to Grafana Labs. The largest cluster we have ingests 180 terabytes per day. Our queries regularly peak at over 900 gigabytes per second. We have found implementation bugs and constraints in all major cloud providers, some smaller, some bigger. We can tell you precisely who oversubscribes, undersubscribes, and everything in between, because Loki is so fast. According to the technicians at the various major cloud providers, we have pushed this beyond what they have seen before. So whatever your storage can do, Loki will just use it. Also, if you have like your own setup, be careful, because Loki can be really aggressive. It can take all the I/O if you let it. And what you see here is basically we had a relatively or pretty complex query, and it took us 12 seconds to query through 10 terabytes of data. Try this at home with a different solution. Tempo for traces, again from the LGTM. The traces is, along with profiles, is an example of full story. So you get the most data out of it at the highest cost. Historically, a lot of projects, a lot of vendors will have told you you need to put the absolute maximum amount of metadata on your traces for them to be useful. And then they do automated analysis and everything and tell you this is the golden path. Consequences of this, sometimes you only have down to 3 days of retention. So if you have a long weekend and you have an outage during that Easter weekend, those 3 days are already over, so you don't see anything of what happened. With Tempo, we have 14 days because it's so much cheaper for us to store stuff, because we don't have as much data. Because the point is this: by attaching a lot of metadata to my traces, I'm basically artificially increasing the size of the haystack in which my needles live. And I have to search a lot, again and again and again and again. But I already optimized my data. I already had people who went in and said, okay, this is a key event. This is a metric. I already have industry experience and I can learn from others. I have my upstream code, I have my vendors who already have subject matter expertise and all the faults they ran into and already made optimizations from this full story into key events, into metrics. So why don't I use this optimization? Why do I throw all this optimization away and artificially increase the search space just for my traces? Doesn't really make sense. Who here knows what exemplars are? So back many moons ago, 2017-18, when with my Prometheus hat on, I wanted to create something like the Prometheus exposition format as a general standard called OpenMetrics. And I actually met with Google about potentially joining forces between OpenMetrics and OpenCensus. Didn't work out. OpenTracing joined with OpenCensus. This is now OpenTelemetry. But during this time, we had a few conversations. And I told them I want the standard label-based for metrics. And they were like, yes, makes sense. And we have this in Kubernetes and Borg and all of those things. And then I told them, and I want to have the same for logs. And they told me, yes, this makes sense. This is what we now have with Loki, label-based logs. And then I told them, and I want to have the same for traces. And they told me, and I quote, no, searching for traces does not scale. So when Google tells you that searching for something does not scale, they probably did the math. The fundamental problem they ran into is, again, the amount of metadata. You need to maximize the amount of metadata. You need to artificially blow up the search space, and only then do you start get value from this. This is not how they chose to do traces. What they chose instead was exemplars. Exemplars are super simple. I could also just call them foreign keys, and everyone was like, oh, yeah, okay. I basically attach an ID, trace and or span ID, to my traces, to my metrics, to my logs, which are already the more optimized forms, and I can jump directly into my traces. So I have this and that high latency bucket, and I happen to have an exemplar on it. I don't have to run the whole query through my traces. I know there's a high latency bucket. I know there's people who have slow queries. And I see the exemplar, I click it, I jump in, and I'm in this trace. And I have all the mental context of this is actually, like I know there is a slow query in there. I don't have this problem of sampling everything away and then onboarding myself for 20 minutes on this trace and then no, it's the wrong one and I need to get the next one. I know it is in there. I have this one HTTP 500 in my logs and I know that log line with an exemplar attached is about a server error. So I jump into my traces and I know in this trace somewhere there is a server error. So again, I spare myself all the searching for the computer and myself all this mental onboarding and is this really the right one or do you need a different one? Because I already know for a fact that those are coming from my high latency, from my errors, from my whatever. Tempo also supports searching. Of course, people also need to search in some cases. It's basically like CSS from the interface to SQL. But it's not the happy path in my opinion. And obviously it's compatible with OpenTelemetry tracing, Zipkin, Jaeger, all the usual. At Grafana, we ingest 1.5 million samples per second, per like cluster, at a sustained 450 megabytes per second, peaking to 550 roughly. If we get to more, we just turn down the sampling ratio. We don't throw away traces by sampling, we just don't create them. Because the thing about sampling is I do all the work, all the overhead, all the expense of compute and RAM and everything to then just throw everything away during sampling. We only generate stuff which is useful. Yeah, and I mean, you already read the retention and the P99 and everything. If the P99 doesn't tell you anything, that's basically the buckets of how bad queries can get, and these numbers are best in class, is basically the point of the slide. Now we come to profiling, Pyroscope for profiling. Who here knows what profiling is? Okay, so profiling is I go into a program and I write down how much CPU, how much RAM do I use in this program, and I don't just do this per program, I do this per function. And I don't only write this down once, I write this down 99 times per second. Not 100, because else I would be like landing on cron jobs and everything, and everyone is having a bad time. Not 101, which would be prime, because Google chose 99, which is not prime, but whatever. It is 99 as an industry standard across CNCF, so we also chose 99. I write down 99 times per second how much CPU, how much RAM am I using in what area of my code. So now I can easily see, here I use a lot of CPU, or here memory keeps increasing and then the killer comes and kills my process. Then I already know roughly where to look, because I need to look where my RAM usage ballooned the last few seconds. So a little bit on cost savings. Just looking at going from logs to metrics as in optimizing a less efficient but more verbose data type into a more efficient, less verbose data type. If you full text index logs these days, you roughly double the amount of storage. Which is really impressive. Of course, in the early 2000s, it was 17x the overhead. Now it's 2x. Really impressive. Compared to this, on average, across all of Grafana Labs, Loki, for the same 10 terabytes of logs, has roughly 200 megabytes of index. So you need to search through 200 instead of 20 terabytes. 200 megabytes instead of 20 million terabytes. Megabytes. You know what I mean. Like, several orders of magnitude of words. It is substantial what you already, every single time you search, do not have to walk through. We average at Grafana and all our customers roughly 600 bytes per log line. Just big average across everything. Metrics across basically all of CNCF and everything is roughly 1.36 bytes per metric. So my reduction of the 200 megabytes, notwithstanding on the index side, on the sampling side, I can turn my 600 byte on average into 1.36 bytes on average. But this is only for the first time. If I turn an error into a counter for this error in a 2-hour window, the first time I see this error, I reduce the size by 99.8%. The second time, I reduce this by 100%, because I just increased the counter. And on average, the extra cost of increasing a counter or different number sizes within Prometheus is on average 0. Double delta and compression, blah, blah, blah. Again, find me later if you want to know more. But this is the amount of resources you can save yourselves by going from logs to metrics. Another one, for those who don't know, at Grafana we have a system of hackathons. 4 times per year. Everyone gets a full week and they can do whatever they want. Learn something new, do a new project, do a new whatever. Only rule is at the end you have to present a 5-minute video of what you did. Then we do voting and we have a winner and everything. But this is basically the hackathon. You can really use this to just learn any technology if you want to. One of us chose to learn profiling when profiling was still new within Grafana. Within 2 days, they had found a workload, which we run a lot, and where we thought we had an optimized chain for text concatenation, but we had the absolute box standard classroom example of Go text concatenation. No optimization at all, but it's no problem because we don't call it often. Turns out we call it quite often. We saved 5 figures per month in compute as a direct result of a single person deciding to look at what this profiling stuff is during the hackathon. And they did it on day 2 of the hackathon. It's an extreme example, but it is a real example of what you can achieve by just looking what is actually happening in your systems. So the second slide on actual Grafana, because as you saw, I completely skipped on what Grafana even is, because everyone knows. You can actually, with Grafana, go all the different ways between the different fundamental data types, from logs to traces, metrics to traces, logs to everything. Kind of obvious. This is how it looks. Most people call it beautiful. I would tend to agree. It's also fun to work with. You can also do geo-information relevant to the industrial people in here. With Canvas plugin, we have the ability to also visualize really complex flows of your power plant or whatever, open valves, whatever. Also starting to have control in there, so you can click a button and something changes in your system. All of what I just talked about is open source, except for the Datadog and such querying from Mimir. That's the one thing which I talked about which is not open source. Everything else which I talked about is fully open source. You can absolutely run it yourself. We do like food and shelter, so if you want to pay us, there's 2 salespeople if they want to stay up. But maybe they run away if they're singled out. Yeah, and that's it. So, we probably have time for one question, and while we get the question, I'm going to do one selfie to track my travels. If you don't want to be on the photo, it's not going on social media or anything. Thank you. So if we have time, we have 20 seconds left. Or everyone gets their break. No one? I promise I don't bite.
Okay, I'm going to ask because there's no other questions. So for us, we use Sentry as a tracing tool. Sentry has many other things, but also it does tracing. Do you know Sentry at all?
Yeah. I mean, not deeply, but I know of them. Yeah.
How would you compare Tempo, was it? Versus Sentry and the tracing capabilities that we have there?
So I'm really careful to not call anyone else's baby ugly. Tempo is optimized for storage of the traces and for searching the traces. You need Grafana to basically have a nice UI. Like Tempo has some baseline stuff, but you really want to use Grafana. So that's the first difference, where you have a clean separation between layers. Whereas my understanding is Sentry is more mixed. If you want to do end-user monitoring, Sentry tends to be more feature-rich. But with Faro, which is a Grafana project, we have something for end-user and for front-ends as well. Same as Baylor, which we just donated to OpenTelemetry successfully, and same as some of the profiling stuff which we donated to OpenTelemetry. We are also in the process of donating Faro to OpenTelemetry, simply because we believe that having stuff upstream and in open source is going to be the more efficient and effective way to build software long term. So I know what I would bet on if I was to make long-term decisions, but also I wouldn't call anything else bad here. So.
Thank you. So you're saying we should look into this, huh?
I mean, you should look into this, yes. I would encourage you to look into everything which I just talked about.
Hello?
Yep.
So regarding what you explained about Loki, I'm not sure I fully understood. So is this like a drop-in replacement for Elasticsearch, or is the model different? Like, you know, do you have to think differently than just send the logs and store them, or can you like elaborate a bit on that?
Yeah, absolutely. It is different. Loki is an example of full text indexing. So you have, again, this roughly doubling of overhead of just storage. Also, what full text indexing does is every single time you search, you have to look through through a lot of data, obviously. So every single time you run a query, you have all this compute, all this memory, all this bandwidth, all this storage overhead of dealing with this lots and lots more of data. But the thing is, you will never search for A or the or even error. You will maybe search for error 500, but you will never search across all of the systems which you have just for error, because it's just too much and it's too unspecified. So this is already something, but you still use a full text index to index all of those. And this is not limited to Elastic or anything. This goes for everything which does full text indexing. You index basically everything. It's super expensive. There are some attempts already by some vendors and some projects to reduce this, but then they have the problem of some of the built-in assumptions start to break down if you don't have complete full-text index. The other portion of this is with the Loki approach to things, or maybe more like the Google and Prometheus and Kubernetes approach to metadata, which Loki is also using. Again, this is labels, and you can see this in the slides if you look at them later. We only index the labels. So part of the problem is everyone has logs, sure. Sometimes you have fully structured data or logs, sometimes you have completely unstructured. And if they're right structured, it's just the wrong type of data. You almost never have something which is fully structured. What Loki does is it allows you through PromTail or Grafana Alloy to look at the data as it comes in and mangle the labels. As in, you can change them, you can add them, you can substring search, whatever, and you can attach those labels. I can click back real quick and I can show you. You can put this into this well-defined format. This is metrics, not logs, but it doesn't matter. You can put it in this format. The beauty of this is you're not dependent on your vendor, on the upstream project, on that one team which keeps fighting and ignoring you to change the data. You do it in the pipeline in flight. The next thing about this is you automatically scale horizontally with however many teams you have as internal customers or whatever, how many clusters you deploy, because this functionality lives close to wherever your workloads are, scales horizontally with them, wherever it's coming from, and in the center you only get the clean version with all of those labels. Then you do the search on the label. And now, let's say, again, you have this HTTP 500 error. If you search through, let's stay with the 10 terabytes, you have 10 terabytes of data. So you search for HTTP error 500, and you search through 20 terabytes of data to look through your 10 terabytes of actual data. Whereas if you search through a Loki log, you have 200 megabytes where you just look for HTTP status equals 500. And this becomes more and more of a lever the more you know about your thing. And you always know something. Even if you only know there has been an error, you know it's this deployment, you know it's this team owning this, it's this region, it's maybe this version. Maybe you don't know the version, maybe you do. But with this, you cut down the search space, even of this already massively reduced amount of search space of 200 megabytes. You cut it down even more by sometimes up to an order of magnitudes by just applying a few labels and cutting this whole search space to almost zero. So when you then do deeper text search within whatever your log line is, because you only pre-select based on the labels, and then you can do really deep, rich text analysis on the actual string. So now you can do your searches, your substring, your regex, your whatever. But you don't have to run this regex across basically 20 terabytes of stuff. You do this only across this tiny amount of data which is left at those speeds of up to 900 gigabytes per second and more. And that is part of why Loki is so much quicker, but also it is fundamentally different in the approach from full text indexing logs. And if you come into this with a mindset of, I always need to full text search, you're going to have a little bit of a bad time. You can do it, but it's going to not make you super happy. So part of being honest here, but this also ties back to why have things become buzzwords, why have things become industry trends. It is not just about keeping on doing what you always have done. It is also basically about learning what others have done successfully to be really able to replicate this success. So it is also a story about teaching and empowering the users about, hey, this is how you can do it so much better. And as a trade-off, dear user, dear developer, you can store so much more data. You can search it so much more quickly. And this is basically the trade-off.
Perfect. Thanks a lot, Richard.